Alrighty, welcome back. Let's take a look at 61 through 65. Annie drives 1/3 of her trip at 60 miles an hour. Then they speed up to average at 65 miles per hour for the whole trip. What is the second velocity? Okay, we're going to want to recall that average speed is going to be E or G, doesn't matter. It's going to be the total distance over the total time. Oops. Okay. Well, that's going to be one leg of the trip, and there are going to be two times involved. One time where she traveled some distance at 60 miles an hour, plus the time at the new speed, which we're going to be calling x. Okay, now how do we get those times? Well, time, if we rearrange the speed formula, that's going to be distance over the speed. So, putting that all into this equation, that becomes 1, and the distance she covered was 0.33 repeating. We're going to want to put at least 4 threes there in your calculator. Divided by 60 miles an hour plus the 2/3 repeating, add some new speed. And all of that is going to equal 65 miles per hour. And so we're going to have that solve for x in our calculator. And when we do that, we get 67.8 miles per hour. All right. 62 is an underflow problem, and it's got a bit of a twist to it because there's a negative number, and if you try doing the normal algorithm of the underflow or overflow, you will try to take the log of a negative number, and then that's gonna wreck you because the calculator is gonna say you can't take logarithm of a negative number. So ignore that part when you start it. Okay, so what do we want to do? The first thing we want to do is resolve that exponent of the 183, and by rules of exponents, we're going to multiply that by the 756. So we'll first start out by saying that we're going to be working with 0.00, oops, too many zeros, 249 raised to the, and now we're going to take the 756 and we're going to multiply that by the 183. And I get raised to the 138,348. And I know there's a negative number there, but we're not going to worry about that right now. Okay, so where do we go from here? Well, when we want to resolve this, we want to write our number as in one number, decimal, times 10 to the power. The problem is that if we just try throwing this into the calculator, right, it's going to say this number is too small. It's going to say 0 or something. Okay, so what do? We're going to take log of that whole situation. And so it turns out, if we go working over here, our answer is going to be 0.00249 raised to the 138,348. So we take log of both sides, so that log of the answer is going to be equal to 138,348 times log of the 00249. And this is where you would want to ignore the negative for now. Just pull it off to the side. Really, the negative's over here. And so when we do this, we get 0.00249. And then we log that. And we get negative 2.60. And then when we multiply that by the 138,348, log of our answer is going to be equal to that. So we'll just keep propagating that statement down to on the left side of the equal sign. So this becomes negative. I'm going to really resolve this as positive. 360,230.612. All right, but I'm going to pretend actually that negative is still out here, okay? Because this gets dumb, okay? This is where the numbers appear right, but I don't think I agree with the key again. Man, I always have these gripes with the keys, right? It's my ego. I'm sure I'm messing something up. That's why I'm writing out the A and the negatives and all that here, just to make sure that everything comes out correctly. So there's still a negative there. Okay, so when we do the overflow, sorry, I'm trying to write and think at the same time here. 7 to 7, when we multiply all that out, what we need to do is we need to break this up into a fractional part and an integer part. So this right here is called the fractional part, and this right here is called the integer part. Now, right now we have log of our answers equal to those two parts, an integer part plus a fractional part. But what we really want is the answer, not log of the answer. So what we do is we raise that back up to the 10, and we apply the rule of exponents. So this becomes 10 to the integer part times 10 to the fractional part. And so dropping down some of that, we get that our answer, oh, I thought I changed it back to sky blue, come on. There we go. That's going to become 10 to the 3 -360,231. Oops. Okay. And what I did is I kept that negative part right here. There really should be positive, but again, we're going to pretend that we ignored that negative from the solution, because the calculator doesn't, the solution doesn't keep it. All right, and then when we do 10 to the fractional part is going to be the 0.6127. And when we do that, that becomes 0.244. Well, it was really 230, but then the 0.244. When we move that over one time over, that becomes 2.44 times 10 to the negative 360,231. And again, there should be a negative right here. And so there's our answer. All right, let's go ahead and continue with the next one. A rubber ball bounced off the floor and travels vertically, striking the floor again at 1.4 seconds. What is its initial velocity as it left the floor from its initial bounce? Okay, well, this thing is going to take 1.4 seconds to go up and then come back down. So it really lost its speed to the top in 0.7 seconds. Well, the acceleration due to gravity is 32.17 feet per second squared. So we're going to change that speed at 32.17 feet per second every second, and we're going to do that for 0.7 seconds. So when we do that and we multiply the two numbers, we get 22.5 feet per second. Now we have to convert that to miles per hour. So we divide by the 5280 miles per hour, miles or feet in a mile. Ooh, man, I am all jumbled up. I need some sleep. Come on, rivers. I keep saying that. I'm like trying to be patient, but like FFS. Feet per mile. And then there's the 3,600 seconds in an hour. So it's the same thing as dividing by 22 over 15. So let's see here. Or 15 over, yeah. So 3,600, multiply that, 5280 divide, and we get 15.4 miles per hour. My friends are having fun. Okay, let's take a look at 64. 64 looks intimidating. They want us to find this side length. So let's see here. Side length times cosine of 25. Now this is going to be 90 degrees here. And this all has to add up to 90, so 180. So this right here actually ends up being the complementary to 25. This is going to be 65 degrees right here. And now why do we want that? Well, it turns out side times cosine of 25 degrees. That distance right here plus this distance right here, which is the side times cosine of 65, all of that is going to equal the side length, because this is a square of 965. So put that in your calculator in the solver. 965 equals side cosine of 25 plus side cosine of 65. Get your side length. All right, last one. We have a quarter circle. They tell us something about the shaded area, and they want us to find out the big radius. So the idea here is it's going to be pi big R squared over 4 minus pi little r squared. That's going to equal 580. Now, how do we solve for the big radius? Well, we're going to need to write the big radius and the little radius in terms of each other. Now, looking at this right here, we happen to have a square at the point of tangency. The radius and the radius extend to these two lines, and so we get a little square right here, and so this is going to be 45 degrees. Okay. Now, the neat thing about this is that this circle, we're going to make the assumption, well, that right here, that radius right here, okay? So looking at this entire distance, from here to here, that's the big radius r, and it's going to be equal to the square's diagonal right here. Now the square's diagonal, if each side is r, this is going to be square root of 2 times r. So if we put this all together, we get that square root of 2 times r plus r, and those are little r's, all of that equals big R. And we're going to go ahead and make a substitution and say, well, let's first factor some things. Square root of 2 plus 1 times r is equal to big R. So I'm going to write little r in terms of big R. Square root of 2 plus 1, all of that right there. I'm going to substitute that in right over here. Or you could do a multiple equation solver with this guy and this guy over here, and then have it solve for the radius. You do that, and then you get 48.5. Alrighty, that's it for the